Hey space enthusiasts! Get ready for one of the most thrilling discoveries of the decade. Astronomers have, for the first time, witnessed the spectacular collision of two neutron stars, capturing both gravitational waves and gamma rays from this cosmic event. Let's dive into this groundbreaking discovery. On August 17th, the LIGO-Virgo collaboration detected gravitational waves from the merging of two neutron stars. Simultaneously, NASA's Fermi Gamma Ray Space Telescope picked up gamma rays from the same event. This coordinated detection has astronomers buzzing with excitement worldwide. This extraordinary event allowed astronomers to point dozens of telescopes and detectors, both on Earth and in space, towards a distant galaxy. They captured radiation across the electromagnetic spectrum, from gamma rays to radio waves. These observations mark the dawn of multi-messenger astronomy, providing crucial insights into how heavy elements like gold are formed in the universe. Moreover, this event offers a new and independent way to measure the universe's expansion rate. The gravitational wave signal, named GW 170817, was the loudest ever detected by the LIGO detectors in Hanford, Washington, and Livingston, Louisiana. The Virgo detector in Italy also picked up a fainter signal, confirming the event's occurrence. The merging neutron stars likely created a powerful jet, producing the observed gamma rays. Using data from 3 detectors, the LIGO-Virgo team pinpointed the location to about 28 square degrees of the sky. Further observations revealed the source as the galaxy NGC 4993, about 130 million light-years away. Among the researchers was Niall Tanvir from the University of Leicester, who immediately initiated observations using telescopes in Chile. The data matched theoretical predictions remarkably well. The gravitational wave signals lasted about 100 seconds, significantly longer than previous detections from black hole mergers. This duration helped astronomers estimate the neutron stars' masses to be between 1.1 and 1.6 times that of the Sun. High-energy gamma rays were detected just 2 seconds after the gravitational waves, confirming that neutron star collisions power short gamma-ray bursts. Francesco Panarale from Cardiff University stated that this finding solves one of the biggest mysteries in high-energy astrophysics. The simultaneous arrival of gamma rays and gravitational waves also confirmed that gravitational waves travel at the speed of light, allowing physicists to conduct stricter tests of Einstein's general theory of relativity. This discovery opens up new frontiers in our understanding of the universe. Stay tuned for more exciting updates in the world of space and science. Don't forget to like, share, and subscribe for more cosmic wonders.